This video is on baby step 5 of dimensional analysis. It's the last step, but strangely, it's going to be about how we start dimensional analysis problems. The way we start them is sort of a modification of the way you worked problems probably in 7th or 8th grade. I say that because I stole these questions from an 8th grade math worksheet. So baby step 5 is all about how we set up a problem because we can use a shortcut based on something you learned and used in middle school math. So here's the problem for Exhibit A. During the first 3 days of the county fair, 1,254 funnel cakes were sold. That's a fact that they've given us. That's a ratio, so we could write it as a fraction style ratio, where maybe on this one I put 3 days on top, and I'm going to abbreviate funnel cakes FC, and then maybe on the other version I put the funnel cakes on top. So I've taken the fact, the ratio fact, and I've turned it into fraction style like conversion factors. So then the rest of the problem says, how many funnel cakes might be sold in 10 days? So in the 8th grade, this is how you would set it up. You would say X funnel cakes over 10 days, and then you would come to these two ratios and decide which one matches, like has the same information on the same sides, since we're looking for equivalent ratios. So you would have picked this one, which means you would write 1,254 funnel cakes on top and 3 days underneath. And so that's how you would have started the problem in the 8th grade. And then you needed some mathematical operations so that you could solve for X. Since X is not alone, we want to isolate X. The first thing you would do is multiply both sides by 10 days. So both sides multiplied by 10 days. What that lets us do is divide these out, and now X is alone. And I'm just going to rewrite that down here. So X, and I'm going to use my funnel cake abbreviation, equals sign 1,254 funnel cakes times 10 days over 3 days. Well, multiplication is commutative. I can multiply things in any order I want to. So I don't have to do 1,254 times 10. I could do 10 times 1,254. So I'm just going to rewrite it looking like that. So here's my X funnel cakes. I'm going to start with the 10 days this time. And then I'm going to say times 1,254 funnel cakes. Put the whole thing over 3 days. So if I use my little highlighter, I can show you that the problem asked how many funnel cakes in 10 days, and that information is all together right here, separated by an equal sign. That's what I call a setup in a dimensional analysis. So let's take a look at another example. This is also a middle school math problem. So the fact that they're giving us is a maglev train travels 310 miles per hour. So if we want to turn that into a fraction style ratio, I would put 310 miles on top and 1 hour on the bottom. Could also do the reciprocal of that, where I say if that train travels for 1 hour, it would go 310 miles. So there's our fact turned into a conversion factor. The rest of the problem asked us, if we were going to travel to New Orleans from Austin, that distance is 508 miles, how long would it take? So we would set it up like X hours over 508 miles, which is how far we're going to travel. Then we'd come over here and pick the one that matches for the other side of the equal sign. That would be this one right here. So I'm going to write in my 1 hour over 310 miles. So then we would need to solve this. So we need to show all of our operations. We need to isolate X. So we'd multiply both sides by 508 miles. That lets the 508 miles divide out and cancel, and X is alone now. So I'm going to rewrite it down here, X hours equals, and since I'm going to rewrite it, and I know these two things are multiplied, I'm going to go ahead and switch them around. I'm going to start with the 508 miles, and then I'm going to multiply it by my 1 hour and divide it by 310 miles. So if I switch back to the highlighter, the problem asked how many hours to go 508 miles. And now I've put it all together as X hours is equal to 508 miles. And then, let's see if I can change color. Yes, I can. This is what we had said in the beginning was one possible version of that ratio statement, and it's all still held together the way we wrote it up there. So it's like we dragged this down here. It's like we read this problem, said how many hours will it take to go 508 miles, and then we just pulled in the appropriate ratio so that the miles would cancel. So let's switch back to the pen. So really the main idea of this whole baby step is because we know we're going to, don't tell your math teacher I said this, cross multiply both sides by the denominator. It's always going to end up with x by what you want, an equal sign, and then the number that was given in the problem. So we can just take a little shortcut and we can set up the problem that way. Here's what I mean by we can set up the problem like that. You don't have enough information on any of these problems to actually solve it and give me an answer. So we're just focusing on, I'm going to read a word problem and I'm going to set it up like we're going to in dimensional analysis. So for the example, you have $45. How many roses can you buy? Well, what you want is roses. So X by your wanted unit, roses. Equal sign, the number that was given in the problem, 45.00, and then the unit. For money, it actually comes in front of the number. So we know what would happen next is there would be some sort of a ratio that would go in here. Maybe if we knew the cost per rows, that would go in here. You don't have it, so you can't solve it. But this right here is what's called the setup for dimensional analysis, and now you're ready to use baby steps 1 through 4 to finish a problem if you had all the information.